A matrix is a collection of information in number form. It is always stored in rows and columns. Each of the numbers in a matrix is referred to as an element or a member of the matrix. Right in front of our screen, we are looking at a form of a matrix. It's a matrix that is in the form of m by n, meaning that it's having m rows and n columns. In this tutorial, we'll be looking at the types of matrices there are. This is Kisembo Academy, and thanks for tuning in. So right in front of us, we are having elements in a matrix. This is element A, but they are in forms of m rows and n columns. By rows, I mean these are the rows, and then the columns are those ones. So when I say A11, A subscript 1, it means that it is in the first row and first column. A21, 21 simply means that it is in the second row but in the first column. And this element here is in the third row but in the first column. This element here is in the second row and second column. This one is in the third row and second column. That is how we categorize, or that is how we name the elements in the matrix. We arrange them in terms of rows and columns. And this, therefore, is a matrix of a 3 by 3, a 3 by 3 matrix. A 3 by 3 matrix means that it is having 3 rows and 3 columns, as we shall see later on. Now let's look at the types of matrices. We have what we call the row matrix. These ones only have rows. For example, this 3, 5, ABC, 9, 4, 1, they only have rows. We have what we call the column matrix. These ones only have columns, like 3, 5, 2, 3, 3, ABC. These ones are just columns. Then we have the square matrix. In a square matrix, we have the same number of rows and columns to just make the square, just like we all know that a square has a property that it has the same number of, a square has equal lengths in all its sides. So if you look at this, it's having 1, 2 rows and 1, 2 columns. If you look at this matrix, it's having 1, 2, 3 columns and 1, 2, 3 rows. So the same number of rows and same number of columns makes it a square matrix, just like this also. The columns are 1, 2, 3, 4. And the rows are 1, 2, 3, 4. So this is a 4 by 4 matrix because it has 4 rows and 4 columns. This is a 3 by 3 matrix because it's having 3 rows and 3 columns. This is a 2 by 2 matrix because it's having 2 rows and 2 columns. And because they are having the same number of rows and the same number of columns, we call them square matrices. We have what we call the rectangular matrix. The rectangular matrix has different number of rows and different number of columns, just like a rectangle. The length of a rectangle is not the same as the length as its width. They are different sizes. So like here we are having 1, 2 rows and then 1, 2, 3 columns. So this one is a rectangular matrix, same as this. It is having 2 columns and 1, 2, 3 rows. So because the number of rows and columns are different for these two matrices, for every matrix, then it qualifies to be called a rectangular matrix. Then we have what we call a null or zero matrix. A null or zero matrix is simply a matrix whose elements are all 0, as simple as that. Then we have what we call the identity matrix. An identity matrix is simply a matrix with the elements in their leading diagonal being 1. If you look at this, we have 2 diagonals. We have this diagonal and that diagonal. This diagonal is what we call the leading diagonal. And if all the elements in the leading diagonal are 1, then that is called an identity matrix. All the elements are 1 and the rest are zeros. If you look at this matrix, we have that diagonal and that diagonal. What we call the leading diagonal is this one. That's the leading diagonal. Now, if all the elements in the leading diagonal is 1, 1, 1, and the rest of the elements are all zeros, then that is called a unit or identity matrix. Let's take an example here. Four senior 3 students, Agaba, Mbazira, and Mororwa, and Kaleba were asked how much pocket money they received. During term 1, A received 20,000, M received 50,000, and C received 10,000, and K received 20,000. During term 2, A received 20,000, M received 90,000, C received that, and K received that. They're asking us to represent this information as a 4 by 2 matrix, and then Roman 2 as a 2 by 4 matrix. We begin. So we shall begin by first of all summarizing our question. They're telling us that there are 4 senior 3 students. These 4 senior 3 students are Agaba, we call him A, Mbazira, Mororwa, which is C, and Kaleba, who is K. Those are the 4 students, and they were asked how much pocket money each received. So these are the 4 students. How much pocket money did they receive? Now during the first term, A received 20,000. So we shall say during term 1. So during the first term, A received 20,000. M received 50,000. This one received 50,000. C received 10,000. C received 10,000. And K received 20,000. And K received 20,000. That is in the first term. Then what about during the second term? During second term, A received 20,000. So let's look at the second term. Remember, we're just summarizing the question. So during the second term, A received 20,000. During second term, A received 20,000, M received 90,000. Then C received 20,000, and K received 10,000. So after summarizing the question, we're supposed to present this information, 1 as a 4 by 2 matrix. This is the information now we have extracted from the question, and we are being asked to represent it as a 4 by 2 matrix. Now when they say represent this matrix as a 4 by 2 matrix, it simply means that this matrix must have 4 rows and 2 columns. Just like we had intimated earlier, that an M by N matrix has M rows and N columns. So it means when they're talking about a 4 by 2 matrix, it means it's having 4 rows and 2 columns. So it means that we are going to design these figures in such a manner that we are having 4 rows and 2 columns. So in making a 4 by 2 matrix, we rearrange these figures in such a way that we are having 4 rows. So if you look at this, we have 1, 2, 3, 4 rows and 2 columns. 1, 2 columns. So this is a 4 by 2 matrix. And we rearranged this, meaning that the A is here, this M is there, this C is here, and this K is right here. So, and then the terms, the first term monies are here, then the second term monies are here. That's a 4 by 2 matrix. So it means that a 2 by 4 matrix will be the reverse. It will be 2 rows, which is that, and then 4 columns. 1, 2, 3, 4. And that's a 2 by 4 matrix. In this video, we get to look at how we add and subtract matrices. As a rule of thumb, first of all, for us to be able to add and subtract matrices, they must be of the same order. By same order, I mean that they are having the same number of rows and same number of columns. For example, when you look at matrix A, the order of this matrix is 2 by 2 matrix. Matrix B, the order is a 2 by 2 matrix, meaning it's having 2 rows and 2 columns, and even this one has 2 rows and 2 columns respectively. So because they have the same order, we can add them, we can subtract them. But if they are not having the same order, then we can't add or subtract them.
This is Kisembo Academy, and thanks for tuning in.
When we are adding or subtracting matrices, we simply add or subtract the corresponding elements in the different matrices we are dealing with. as we are going to look. For example, let's find A plus B. We have matrix A, which is 2, 3, 8, 0. We have matrix B, which is 1, 4, 5, 6, and we're supposed to add A. So meaning to add matrix A plus B, it means we are adding matrix A, which is 2, 3, 8, 0, plus matrix B, which is 1, 4, 5, 6. So the answer to that is going to be this. We are going to add this corresponding elements. So this is going to be 2 plus 1, which is 3. 3 plus 4, which is 7. Then we have 8 plus 5, which is going to be 13. Then we have 0 plus 6, which is 6. And that's the answer. We've added A plus B. Let's go on to the next example, B minus A. B minus A means that we are going to get matrix B, which is 1, 4, 5, 6, 1, 4, 5, 6, minus matrix A, which is 2, 3, 8, 0, 2, 3, 8, 0. So subtracting those means it's going to be, we are going to get the corresponding elements in the two matrices and we subtract them to get our answer. So we get the topmost one, 1 minus 2. It is 1 minus 2, giving us negative 1 for that slot. Then for the next slot here, it's going to be 4 minus 3. 4 minus 3 gives us 1. So for this slot here, it's going to be the corresponding elements, 5 minus 8, giving us negative 3. Then for this slot here, it's going to be 6 minus 0. 6 minus 0 gives us 6. And that's the answer. That's how we add and that's how we subtract matrices. Let's go into our third example. Our third is giving us 2A plus 3B. So here we are having a scalar multiplying the matrix, and another scalar here called 3 multiplying it by the matrix B. So it means in this case we are going to have to first multiply the scalar by the matrix, then after that once we add the matrices. Looking at that example, 2A plus 3B. 2A plus 3B means that we are going to multiply 2 times A first. So it's 2 times matrix A. What is matrix A? Matrix A is 2, 3, 8, 0 plus 3 times matrix B, 3B. Matrix B is 1, 4, 5, 6. So we go ahead and multiply first. So it's going to be, when we are multiplying a scalar by a matrix, we are going to multiply this by all the elements in this matrix. So in this case here, it's going to become 2 times 2, which is 4, 2 times 3, which is 6, 2 times 8, which is 16, and then 2 times 0, which is 0, plus 3 times 1, which is 3, 3 times 4, which is 12, 3 times 5, which is 15, and 3 times 6, which is 18. So we shall then add the two matrices in the normal way like we've done before, and we shall get our answer. So when we add the two matrices like before, we find that 4 plus 3 is 7, 6 plus 12 is 18, 16 plus 15 will give us 31, and then 0 plus 18 will give us 18. In this tutorial, we get to look at how we multiply matrices. First of all, as a rule, for you to be able to multiply matrices, the number of rows in the first matrix must be equal to the number of columns in the second matrix. This is Kisembo Academy, and thanks for tuning in. let's make an illustration. When we look at these matrices, for example, these two matrices here, this is a 2 by 2 matrix. This is also a 2 by 2 matrix. But if we are to multiply these matrices, the number of rows in this matrix must be equal to the number of columns in the next matrix. Why is that so? Because in matrix multiplication, we multiply the row in the first matrix by the column in the next matrix. If we are looking at this matrix, for example, when I talk about rows, this is what I mean. This is a row, and that is also a row. Then when I'm talking about columns, this is what I mean. This is a column, and that is also a column, like that. Let's look at this matrix too. Let's look at the rows in the first matrix. In the first matrix, if we are to look at the row has 1, 2, 3 elements. Those are the number of elements in the rows in the first matrix. Then when we get to the second matrix and we look at the columns, there are 2 columns. But how many elements are there in each of these columns? There are 3. So if you look at the first matrix, there are 3 elements in each row, and then in the second matrix it has 3 elements in each column. So it means that these 2 matrices are compatible, so we can multiply them. That is the rule. That is what you have to first ascertain before you go ahead with the multiplication. If that condition is not met, it means that the multiplication cannot happen. It means those 2 matrices are not compatible. So let's go ahead and try and multiply these matrices. Before we start using figures to do matrix multiplication, I would like to first illustrate it using this illustration using letters. We are having this matrix A, B, C, D, which is a 4 by 4 matrix, multiplying it by E, F, G, H, which is also a 4 by 4 matrix. We are multiplying these 2 matrices, but when we multiply these 2 matrices, we are supposed to get one matrix as the answer, and this matrix is supposed to be having 4 elements. That is a 2 by 2 matrix. Now, when we are multiplying matrices, we multiply the row in the first matrix by the column in the next matrix. The row in the first matrix by the column in the next matrix. So we are supposed to do it in such a way that we get these answers. These circles you're seeing here are supposed to be filled by figures, which figures are supposed to be coming from this working. So how do we determine which row we are supposed to multiply by which column? Let's look at the first circle. If you look at this circle, it is in the top row, but in the left column. This circle. If you look at this circle, it is in the top column. It is in the top row, but on the left column. If you look at this bottom circle, it is in the lower row, but on the left column. If you look at this circle, it is in the bottom column, in the bottom row, but on the right column. So this is how we are going to determine which row to multiply by which column. So for example, let's assume that we want to find this answer. What answer do we get here when we are multiplying these 2 matrices? If you look at this figure, this position here, it is in the top row and on the left hand column. So it means that when we are multiplying these matrices, we are going to multiply the top row by the left column. So it means that we are going to get to our first matrix, and we get, since it's in the top row, so it means we are going to multiply the top row by the left hand column. So it means that in this second matrix, it's the left hand column to get this answer. So that's how it comes to being A times E, which is this, plus B times G, which is that. So A times E plus B times G gives us that answer. How do we get this other answer? If you look at the position of this element, it is in the top row and on the right hand column. So it means that for us to get this answer, we need to multiply the top row, which is this one, by the left hand column, which is this one. So that is why in our working here, it is A times F, which is that one, plus B times H, which is that. And we're able to get this answer. Likewise, look at this position. This position is in the bottom row, but on this side of the column, on the left hand side of the column. So it means for us to be able to get this answer, we are supposed to use the row, the bottom row, to multiply by the bottom, the column on the left hand side, which is this one. So it is this row times that column to get this answer. So that's why it is C times E, which is this, plus D times D, which is that, to be able to get that answer. Likewise, in the last one, we are going to multiply C. If you look at this position, it is in the bottom row, but on the right hand column. So it means that for us to be able to get the answer to all the element here, we are supposed to multiply the bottom row, which is CD, by the right hand column, which is FH. So we end up with C times F, which is that, plus D times H, which is that. And we end up getting the answer there. So that is how we are going to do it when we are multiplying. That is how we multiply the row by the column in matrix multiplication. So let's go ahead and do the examples. We are having the first matrix as 9, 6, 4, 11. We are multiplying that matrix by 1, 0, 0, 1. It's going to be like this. So we are going to multiply the row by the column. So it means we are going to get this row first and multiply it by that column. So at first we shall say it is 9 times 1, the first element in the row multiplied by the first element in the column of the next matrix. So it's going to be 9 times 1 plus 6 times 0. 6 times 0. Then we shall get to the next. We multiply this row by that column to get the term down here. So it's going to be 4 times 1 plus 11 times 0. So we get to this other term of the matrix. So again, we are going to multiply the upper part, the row, by that column. So it is 9 times 0 plus 6 times 1. Then we have down here, we have 4 times 0 plus 11 times 1. Then after doing the row by column multiplication, we shall get our final answer. So the rest is math. It's going to be 9 times 1, which is 9, plus 6 times, which is 0. Then down here it is 4 plus 0. Then up here is 0 plus 6. Then down here is 0 plus 11. And our final answer here will be 9, 4, 6, 11. Looking at this example, we are being required to multiply this matrix by that matrix. So using our earlier illustration, we are supposed to be multiplying a row by a column. And in this case, we shall follow through this working closely. If you look at this first step here, it is getting this top. It is if you look at this figure is what is giving us this answer. And this answer coming from this figure is as a result of multiplying this top row by that column. Why? Because the answer we want is in the top row and on the left hand side of the column, in the left column. So it means we multiply this by that, which was 3 times 2, then 1 times 4, then 4 times 1 to get this answer. Likewise, for us to be able to get this 15 is positioned in the topmost part of the columns and on the right hand side of the rows. So it means the column we are going to use is supposed to be the top one multiplied by the right hand side of the column. So we got this 15 by saying 3 times 1, which is that, plus 1 times 0 plus 4 times 3 to get that 15. The same here, for us to be able to get this number 12. To get this 12, first of all, it is positioned in the bottom column, but on the left-hand side of the column. The left-hand side of the column and the bottom row. So it means that if you're multiplying to get this 12, we're supposed to multiply the bottom one, since it's bottom, the bottom column by the right-hand side of the right-hand column. So it is 5 times 2, which is that, plus 0 times 4, which is that, and then 2 times 1, which is that. And this is what gave us the 12. And also, for us to be able to get this number 11 was the same issue. We're supposed to multiply the bottom row by the right-hand side of the column, which is that, to get this, since it is positioned in the bottom row and on the right-hand side of the column. So it was 5 times 1 plus 0 times 0 plus 2 times 3 to get this answer. And this is how we get this 14, 15, 12, and 11 as our answer for the multiplication of that. How to find the inverse of a matrix. When we are asked to find the inverse of a matrix, it's like they're asking us to find the reverse of a matrix. And the formula for finding the inverse of the matrix is 1 over determinant times the adjoint. Now, for us to be able to find the inverse of the matrix, it means that we need to know how we find the determinant of a matrix. Then we also need to know how we find the adjoint of a matrix, so that we are able to substitute it in this expression, 1 over determinant times adjoint, so that we are able to get the inverse. So it means that in this tutorial, we are going to first explore how we get the determinant. Then afterwards, we shall explore how we find the adjoint. And then eventually we'll be able to find the inverse of a matrix. This is Kisembo Academy, and thanks for tuning in. So let's first explore, how do we get the determinant of a matrix? We have an illustration here. If this is a matrix A, B, C, D, and we want to find the determinant of this matrix A, B, C, D, it is as simple as getting the elements in the main diagonal, which is AD, we multiply them, which is this, A times D. Then we also get the elements in the minor diagonal, which is BC, we multiply them, CB, and then we subtract. So now let's look at the two examples that we have here. We are being required to find the determinant of this and the determinant of that matrix. So let's get the determinant of this matrix. To find the determinant of this matrix, we are going to get the elements in the main diagonal. In the main diagonal here we have 2 and 3. So it's going to be 2 times 3 minus 5 times 1. 2 times 3 is 6 minus 5 times 1, which is 5. So it means the determinant here is 1. Let's get to the next matrix. It's 9 times 4. This is in the main diagonal, so it's going to be 9 times 4 minus 3 times 12. 3 times 12, that is in the minor diagonal. 9 times 4, this is the main diagonal, the major diagonal. So 9 times 4 is 36 minus 3 times 12, which is 36. So the determinant of this matrix is 0. So that is how we find the determinant of a matrix. In finding the adjoint of a matrix like this one, we have two diagonals. We have the leading diagonal, which is AD, then we have the minor diagonal, which is CB. So what we do, we go to the leading diagonal and we change the positions. It means that if A is positioned here and D is positioned here, what we are going to do is that in our new adjoint, we are going to put D here and A there. We interchange these positions, we switch them. Then in the minor diagonal, we are going to simply multiply by -1. So it means in this illustration, our adjoint will become, D will go there, so it becomes D here and A here. Then these ones are multiplied by -1, and we will have this turning into -C, and this is -B. And that is our adjoint. Let's do a few examples to illustrate this point. We're having the adjoint of this following, find the adjoint of the following matrices. We have this, so the adjoint of this is going to simply become, we interchange these two numbers in the leading diagonal, so these 3 will come here and the 2 will get here. Then in the minor diagonal, we multiply them by -1. So -1 times 1, that will give us -1, and when you multiply this by -1 gives us -5. So this is the adjoint of that matrix. Let's get to this matrix. The adjoint of this matrix is going to become, we have the 0 here, then the 3, these two interchange, so 3 is down here. Then in this other diagonal, we multiply by -1. So 4 times -1 is -4. Then -1 times -1 gives us +1. And that's the adjoint of this matrix. Let's calculate the adjoint of this matrix. This will become, these interchange their positions. So we have -3 down here, and we have -4 up here, like that. Then in this minor diagonal, we have this 2 times -1 gives us -2, and then -1 times -1 gives us +1. This is the adjoint of that matrix. Then finally, to find this, it's going to, we interchange these ones, so the 2 comes here, and the 3 goes down here. The 2 comes up here, then the 3 is down here. Then we multiply this by -1, this becomes 2, and this becomes 1. So that's how we find the adjoint of the matrix. So we have just learned how to find the determinant of the matrix. We've also learned how to find the adjoint of the matrix. Now that we know how to find the determinant and the adjoint of the matrix, so it means we can now find the inverse of a matrix. Let's do a few examples as well. We have matrix B, which is 2, 4, -3, -4, and we are required to find the inverse of that matrix. To find the inverse of this matrix, we have to first find the determinant, then we get the adjoint, then afterwards we substitute them in here and get the inverse. So we have matrix B, which is 2, -3, 4, -5. To find the determinant first, the determinant of that matrix is going to be equal to the leading diagonal, which is 2 times -5, minus the minor diagonal, which is 4 times -3. And the answer we shall get here is going to be -10 minus 4 times -3 is -12. So we shall end up with -10 plus 12, and our answer is 2. So 2 is our determinant. So we find the adjoint of the same matrix. Adjoint. The adjoint of that matrix is simply going to become, if we look at the main diagonal, we are going to switch the numbers. So -5 comes here and -2 goes down. So this is going to become -5 up there and 2 down there. And then we multiply this minor diagonal by -1. So -3 times -1 is giving us 3. And 4 times -1 is going to give us -4. And when those two are, so meaning here we have the adjoint. So to get the inverse of this matrix is simple. To get the inverse of this matrix, so it's going to become 1 over determinant. Our determinant is 2. So it's 1 over 2 times our adjoint. Our adjoint is that figure we got there, which is -5, -4, 3, 2. And our answer will simply be, this is a scalar. It's a fraction, but it's a scalar. And we say that when we're multiplying a scalar by a matrix, we multiply that scalar by each element in that matrix. So it means that this is going to be a half times -5, a half times 3, a half times -4, a half times 2. And our answer here will be -5 over 2. A half times -4 is going to give us -2. A half times 3 is going to give us 3 over 2. Then a half times 2 is going to give us 1. And this is the inverse of matrix. Find the inverse of matrix D. Just like we did before, we are going to first find the determinant. Determinant of this matrix is going to be 3 times 6 minus 4 times 5. So 3 times 6 is 18, minus 4 times 5 is 20. And we shall end up with our answer being -2. So that's our determinant. So we get the adjoint of the same matrix. The adjoint of the same matrix is simply going to be, we are going to interchange the elements in the leading diagonal. So we have the 6 coming up here and the 3 coming down here. Then in the minor diagonal, we multiply each element by -1. So -4 times -1 is -4. -5 times -1 is -5. So that becomes our adjoint. So it means that our inverse is going to be equal to 1 over determinant, multiply that by our adjoint. So what we do here, we are going to simply substitute. It's going to become 1 over our determinant, which is -2. So the whole thing is 1 over 2 is -2 times our adjoint, which is 6, -5, -4, 3. And then we shall end up as -1/2 times 6 is going to give us -3. -1/2 times -4 will give us +2. -1/2 times -5 is giving us +5 over 2. The -1/2 times 3 will give us -3 over 2. And this is the inverse of that matrix. How to find the inverse of a matrix using the identity matrix method. In our previous videos, we explored another method. In just our concluded video, we talked about how we find the inverse of a matrix, but we were using a different method from this one. Now, in this method of finding the inverse of a matrix using the identity matrix method, we are using this property that when you multiply a matrix by its inverse, you're supposed to get an identity matrix. In our previous videos, still, we talked about the identity matrix, and we all know what it is. An identity matrix is simply a matrix with the elements in their leading diagonal being 1. If you look at this, we have 2 diagonals. We have this diagonal and that diagonal. This diagonal is what we call the leading diagonal. And if all the elements in the leading diagonal are 1, then that is called an identity matrix. All the elements are 1 and the rest are zeros. So in this, all we need to do is to get the matrix whose inverse we want to find. We substitute it here and we forget the identity matrix, substitute it here and we try and get the inverse. We are going to use the same examples we used in our previous videos. Find the inverse of the following matrices. We are going to find the inverse of this matrix and we are going to find the inverse of this matrix, but we are going to use the identity matrix method. This is how we do it. First of all, we want to find the matrix B. That's the matrix given. So B, matrix B, when you multiply it by its inverse, which we are denoting like that, is supposed to give us an identity matrix I. So what's that matrix B? The matrix B is that it is 2, 4, negative 3, negative 5. That is matrix B. We multiply it by its inverse. Now this is what we are looking for. Let's call its inverse A, B, C, D. So when we multiply it by A, B, C, D, then we are supposed to get the identity matrix. The identity here is 1, 0, 0, 1. So our task is simple, to find the values of A, B, C, D. When we find the values of A, B, C, and D, this matrix is the inverse matrix that we are looking for. So here we are going to multiply. We are going to use matrix multiplication. We are multiplying this row by that column, then this row by that column, then this row by that column, then this row by that column. So it's going to be like this. So it's going to be 2 times A, which is 2A, plus 4 times C, which is 4C. Then this row by that column, 2 times B, which is 2B, plus 4 times D, which is 4D. Then negative 3 times A, which is negative 3A, plus negative 5 times C is minus 5C. Then we have this times that. 3 times that is negative 3B. Then negative 5 times D is negative 5D. This is equal to our identity matrix, which is 1, 0, 0, 1. So you're going to find that we are having several expressions. We have 2A plus 4C is equal to 1. Negative 3A minus 5C is equal to 0. 2B plus 4D is equal to 0. Then negative 3B minus 5D is equal to 1. As in, when we add this, we get that. So we formulate, from this, we are going to formulate simultaneous equations from which we are going to find the unknowns. So in this case, it's going to be this. 2A plus 4C is equal to 1. That is one simultaneous equation. Then negative 3A minus 5C is equal to 0. So from here we can find the values of A and C. So when we find the values of A and C, we can use substitution method. We make this one of the unknowns in this and then the subject of the formula. Let's make C the subject of the formula. So when we continue with this, when we transfer this to that side, it's going to become negative 3A is equal to 5C. When we divide both sides by 5, we end up with our value of C here becoming negative 3 over 5A. That's our value of C. So if our value of C is negative 3 over 5A, so it means we are going to substitute for C in the first equation. So where there is C, we put this. So it means our first equation is going to become this. So our first equation, which was originally 2A plus 4C is equal to 1, is going to become 2A plus 4. Now our value of C is now this one. 4 times negative 3 over 5A is equal to 1. And so the rest is math. We now work out and try and get the value of A. So this is going to become 2A. This times that is minus 12A over 5 is equal to 1. So our value of A here, 2A minus that, is over 1. LCM is 5. 5 divided by 1 is 5. 5 times 2 is 10A minus 12A is equal to 1. 10 minus 12 is minus 2A over 5 is giving us 1. And our value of A here is negative 5 over 2. So we've gotten our value of A. So now that we've got value of A, it means we can also get value of C by simply substituting it here. So if our value of A is negative 5 over 2, it means that our value of C is simply going to be negative 3 over 5 times A, which is negative 5 over 2, times A, which is negative 5 over 2. And so here we shall end up with getting our answer as positive 3 over 2. That's our value of C. So now that we have used these two simultaneous equations to get the value of A and C, so we are going to use this pair also to get the values of B and D, just in the same way. So here we have 2b plus 4d is equal to 0. That's one equation. Then we also have negative 3b minus 5d is equal to 1 as another simultaneous equation. So we are going to combine those two simultaneous equations, we solve them and get our value of B and D. So still we are going to use substitution method. We are going to, this is equation 1, this is equation 2. So we will get equation 1. We make one of these the subject of the formula. If equation 1 is 2b plus 4d is equal to 0. So meaning when that one goes that side, it becomes 2b is equal to negative 4d. When you divide both sides by 2, this moves with that. B becomes 4 divided by 2 is negative 2d. So if b is negative 2d, it means that in our second equation, we substitute for b. And where there is b, we put this there. So it means our second equation is going to become like this. Our second equation, which was originally negative 3b minus 5d is equal to 1, is going to become negative 3. Where there is b, we substitute it with that, into negative 2d minus 5d is equal to 1. So negative 3 times negative 2 is positive 6. 6d minus 5d is equal to 1. And then we end up with our 6d minus 5d is d is equal to 1 as our answer. Since we have our value of d as 1, so it means we can also get our value of b by substituting here. So it means our value of b is going to be negative 2 times d, which is 1. This is going to become negative 2 as our answer. So now we have gotten the values of A, the value of B, the value of C, and the value of D. We got our value of A as negative 5 over 2, and the value of C as 3 over 2. A is negative 5 over 2, and our value of C is 3 over 2. Then our value of B is negative 2, and our value of D is 1, just like we did in our previous question. And that is our answer. That is how we find the inverse of a matrix using the identity method. How to solve a simultaneous equation using matrix method. It's Kisembo Academy, and thanks for tuning in. There are very many other ways of solving simultaneous equations. We can solve simultaneous equations using elimination method, we can use substitution method, we can use graphical method, but this tutorial will concentrate on just one of the methods, and that is the matrix method of solving simultaneous equations. We're illustrating using an example. We have these two simultaneous equations, 2x plus 3y is equal to 4, and also we have x plus 2y is equal to 3. These are two simultaneous equations that require to be solved using matrix method. So to begin it off with, we need to first of all extract the matrix we are going to deal with. And we extract this matrix by just extracting the coefficients of the unknowns. The coefficient of x here is 2, so we extract 2. The coefficient of y here is 3, so we get the 3. The coefficient of x here is 1, so it is the 1 there. And then the coefficient of y here is 2, and that's the 2. So we end up with our matrix as 2, 3, 1, 2. So this is the matrix. We multiply this matrix by the unknowns. The unknowns in this case here is x and y. So we follow that order, x and y, because the first term here is x and the next is y. Now if it is the reverse, if it was 2y plus 3x, or if it was y plus 2x, then it means that the order of our unknowns here would be y and x. The order of this matrix, the way we present them, is dependent on which comes first here. Here it is x that comes first, so it is x coming here first, then y comes next, so y next. So this matrix multiplied by xy is supposed to give us 4, 3, and that is the 4, 3. So now we are going to deal with this to find the value of x and y. So for us to be able to find the value of x and y, it means that we need to eliminate this matrix from this side so that it goes this way. We need to remain only with the unknowns here. So now for us to be able to eliminate this matrix, it means that we're supposed to multiply it by its inverse. When we multiply this matrix here by its inverse, it means that we are going to remain with nothing here, or we are going to remain with an identity matrix here, so that we're able to remain with x and y on only this side and the rest is the other side. So it means that we are going to find the inverse of this matrix. When we get the inverse of this matrix, we multiply it on both sides. We multiply it on this side and that side, and then afterwards we'll progress and we'll remain with xy on just one side of the equation. So we begin by finding the inverse of this matrix. In our previous videos, we explored in detail on how to find the inverse of the matrix. So we all know that finding the inverse of the matrix is equal to 1 over determinant times the adjoint. So we first get the determinant of this matrix by saying the major diagonal, which is 2 times 2, minus the minor diagonal, which is 3 times 1, to get our determinant as 1. After getting our determinant as 1, we find the adjoint of this matrix. The adjoint of this matrix we get by interchanging the numbers in the main diagonal, which is 2, with the 2's interchange. Then in the minor diagonal, we simply multiply the numbers by -1. 1 times -1 is -1. 3 times -1 is -3. So after getting the determinant of the matrix and the adjoint of the matrix, then we can substitute it in here so that we are able to get the inverse of the matrix. And it is this inverse that we are going to multiply here on both sides. And this is what is happening in our next step. In our next step, we are going to multiply the inverse of the matrix, which is 1 over determinant times adjoint, times the original matrix, which is that one, this one, times xy, which is that, is equal to 1, the inverse of the matrix, which is 1 over determinant times adjoint, which we are going to multiply, times 4 over 3, which is that, 43. So it's the substitution going on in the next step. So 1 over determinant is 1 over 1. 1 is the determinant times the adjoint, which is this one, which we already got here, times this, times that, is equal to 1 over determinant, which is 1 over 1, times our adjoint, which we already got as 2, -3, -1, 2, times 4, 3. Then the rest is math. So we multiply this by that. And when we multiply a matrix by its inverse, we are supposed to get an identity matrix. So as we are multiplying here, you're supposed to make sure that the final answer you're getting is an identity matrix, 1, 0, 0, 1. Now if you multiply these two and what you're getting here is not an identity matrix, then it's supposed to show that there is something wrong with your calculation here. So we get that, multiply it here, we do the same on the other side. And so, of course, the multiplication, it's row by column. 2 times 2 plus -3 times 1. Then this row times that column to get this. 2 times 3. 2 times 3 plus -3 times 2, which is that. Then we have this -1 times 2 plus 2 times 1. Then we have -1 times 3 plus 2 times 2, which is that. So when we compute all this, we shall end up with the identity matrix times xy. On this side of the equation, it's simply going to be matrix multiplication. This row times that column, then this row times that column. 2 times 4, which is that, plus negative 3 times 3, which is that. Then we have negative 1 times 4, which is that, plus 2 times 3, which is that. And then we compute that and we end up with negative 1 and 2. So now, of course, when we multiply an identity matrix by any matrix, this gives us the same. This times xy gives us xy is equal to negative 1, 2. So it means our value of x is negative 1 and our value of y is positive 2. And so this is how we solve a simultaneous equation using matrix method. We will do one more example. We have a number 2p minus q is equal to 8, 4p minus 3q is equal to 14. We are required to find the values of p and q in that simultaneous equation. So we are going to extract our matrix by extracting the coefficients of those unknowns. The coefficient of the unknown here is 2, the coefficient here is 4, the coefficient here is negative 1, the coefficient here is negative 3. So it means that our matrix here is going to be negative, it's going to be 2, then that is 4, then this is negative 1, then this is negative 3. Multiply that by the order of the unknowns, it's p coming first, then q. So it's going to be p, q, that is supposed to give us 8, 14. 8 and 14. Then after that, then we go ahead and find the inverse of this matrix. When we get the inverse of this matrix, we multiply it on both sides. So the inverse of this matrix is going to be, first get the determinant of the matrix, which is 2 times negative 3 minus 4 times negative 1. We end up with negative 6 minus negative 4. It's going to give us negative 6 plus 4, giving us negative 2. So this is our determinant. So we go ahead and find the adjoint of this same matrix. So the adjoint is simply going to become, we interchange these numbers in the main diagonal, which is, so here we have negative 3, and this 2 comes down here. Then in this diagonal we multiply by negative 1. 4 times negative 1 is negative 4. Negative 1 times negative 1 is 1. So we go ahead and, so it means that our inverse, the inverse of the matrix is going to be 1 over determinant, which is negative 2, times the adjoint, which is negative 3, negative 4, 1 and 2. So after getting our inverse, so we are supposed to multiply the inverse on this side of the equation and that side. So bringing this back, it's going to become 2, 4, negative 1, negative 3 times PQ is supposed to be equal to 8, 14. So we are supposed to multiply this inverse on both sides of this. So multiplying that is going to give us negative a half into negative 3, negative 4, 1, 2 times that is supposed to give us 1 over 2, this is negative, into negative 3, 4, 1, 2. Like that. And then the rest is matrix multiplication and we get our answer.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.